All right, so let's go back to the function that we're going to focus in on this topic here, which is f of x equals the piecewise function x plus 1 for x less than 0. It's going to equal 3 for x equal to 0, and it's going to behave like x squared plus 1 for x greater than 0. And the limit that we want to evaluate, or at least estimate here, is the limit as x approaches 0 of my function f of x. So that means I need to construct a graph of this particular function, and so let's do that now. I know, I'll give myself some points here to work off of. I know that x plus 1 for x less than 0, that's the linear function. It has a y-intercept of 1, it has a slope of 1, so it's coming right here, right up until x equal to 0. And because it's less than 0 and not equal to 0, I know I'm going to start off at least with an open point here. And I'm going to have the linear function that looks like that. Now then, at 0, my function is equal to 3. So I have this point right here. And then the function behaves like x squared plus 1, which is the parent function for quadratics shifted up 1 unit. So I actually have this open point right here, but then I start behaving like a parabola, and there's a graph of that function f of x. And so what I'm doing here, whenever I look at it just graphically, I am estimating the limit, because even though we know what these functions look like, I could be looking at something that was a little bit more complex, and I don't really have the ability to zoom in all the way to 0. So whenever we look at it from a graphical standpoint, we are estimating. But for this particular function, everything's pretty well behaved and pretty easy to analyze what's going on. Well, I can look at the one-sided limits here. I can look at the limit as x approaches 0 from below of f of x. As I'm approaching 0, tracing my function here, the function values are approaching this open point of 1, and that's what this statement right here conveys. The limit as x approaches 0 from above of this function f of x. So as I'm tracing the function from the right going towards 0, again, my function is heading towards 1, and because the one-sided limits matched, the limit as x approaches 0 of this function is equal to 1. And just a reminder with limits, and we've emphasized this several times now, but just because I have this point, 0, 3, doesn't mean, in fact, it doesn't mean anything when it comes to the limit, because the limits are focusing on what's happening as the function is getting close to 0, and that's where I was headed to the value 1. So this point right here at 0, 3, it could have been 0, 2, it could have been 0, negative 3, it even could have been 0, 1. It had no impact on the limit, which is describing the behavior of the function as x gets close to that value.